Good afternoon or good morning. I'm Teresa Ortega, and today I will walk you through the current state of the LAMBKIN SDK. It's the phase 5.6 of the project we have been developed at Ekumen. Before we dive in, a quick look at what we will cover. We have two parts. The first, the SDK itself, what it is, and the concepts behind it. And then a real example, how we use LAMBKIN to evaluate Beluga AMCM. Let's start with the SDK. The first question is probably the most obvious one. What is LAMBKIN? The philosophy fits in one line. The user brings the algorithm and LAMBKIN handles the rest. In practice, it's a Python SDK for building SLAM evaluation pipelines, designed to be reproducible and structured by design. The user focuses on what matters, the algorithm, the parameters, the data, and the SDK takes care of everything around it, running the experiments, organizing the outputs, managing the processes. But what does everything around it? That's what the core concepts are for. Let's start with the name product. The idea, it's simple. You give it a name parameter list, and it gives you every possible combination. Look at the diagram on the right. We have two parameters, sensor model with two options, and number of particles with 3 values. Name product, expand them into the 6 combinations you see below. You pass the result to the benchmark through variants, and the sweep yet happens. The important thing is that this works with any parameter you want. Algorithm flags, ROS datasets, sensor topics, config paths, anything that defines a variant. Variants define what runs, but options define how it runs. So let's look at those. Option is how you register a command line flag on your benchmark. Instead of reinventing the wheel, it's built as a thin layer over click option. This is the standard in the Python ecosystem. So every feature click gives you types, choices, environment variables, callbacks, multiple values. It works out of the box. So 2 things worth nothing. Flag names must start with a dash or double dash. And this is validated when you decorate the function, not when you run it. And all options are parsed once before the loop starts, with their values are made available through the context. So we are speaking of the context, so let's look at what it actually is. The context isn't a single object. It has 3 nested levels. At the base, we have benchmark context that holds everything shared across the full run: source, options, base year, and inputs. Inside it, variant context adds what is specific to each parameter combination, variant and variant year. And inside it, iteration context adds iteration, cell, and skip it. Each level sees everything the previous one exposed, plus what belongs to its own scope. While on the right, you can see the directory structure LAMBKIN creates automatically. There is a variant YAML at the root, and inside each variant folder, one directory per iteration containing its LAMBKIN metadata YAML, whatever actifiers your benchmark produce, and the log files for each process. Input is how you register data hooks that run before the main loop, for loading datasets, maps, models, whatever you need. And a hook takes a single context argument, must return a non-empty value, and gets injected into context input under the function name. In the example, dataset returns a path built from context source path parent, and from then on it's available as context input datasets. But not every input needs to resolve at the same frequency. With a scope benchmark, it resolves once for the whole run for shared data, with a scope variant only when variants change. For example, if each sensor model needs a different recording, and with the scope iteration, if it depends on the specific iteration. Source is a small but a very useful concept. The benchmark knows where it lives. It exposes through the context and gives access to the script on location. So, no more hardcode paths. You always reference files relative to context source. The result is that your benchmark is portable. Some behavior on your machine, same behavior on your machine, college, or CI. The benchmark is what drives everything. It parses the CLI options once before everything else runs. Then it creates a benchmark context for enter run, and right there, before entering the variance loop, it resolves all benchmark scope inputs. Then, for each variant, it creates a variance context, resolve variant scope inputs, and inside the loop, over iteration. Creating a fresh iteration context is each time, resolving iteration scope inputs, and calling this function with it. Once every variant and every iteration has finished, it runs the output hooks, once at benchmark scope. So there are 3 levels of context mapped directly to the 3 levels of input resolution. And the outputs always run last. Inside that loop, you will usually want to call external tools. So cell is the important thing that exposes the host environment executable as Python attributes. Accessing context cell ROS2 backplay builds the command lazily and runs ROS2 backplay. No hardcode paths, no manual subprocess calls. With die run active, it prints the command instead of running them, which is the mode we use to validate the full flow without execution anything. The cell runs commands, but something has to grab them and manage their full life cycle. Background process grabs a cell command and manages its full life cycle. Start, monitor, and clean up. As a context manager, you pass it the cell proxy without calling it, and it takes care of the rest. Process can be nested. The outer one stays alive, while the inner one and both are torn down and exit in reverse order. If a process dies unexpectedly, it doesn't hang. It raises LAMBKIN process die unexpected error immediately. On cleanup, every process spawned during an iteration lives in its own C group, and the kernel enforces containment. Nothing can escape. On iteration end, LAMBKIN sends seek term, waits a grace period, then seek kills anything still alive. And if you press Ctrl+C, that grace directly to C group point kill, and the kernel propagates the shutdown instantly. There are 2 different logging systems, and it's worth keeping them separate. The SDK logging control with log level governs LAMBKIN own internal messages. It's insulated from the root logger, so if you want to root it somewhere specific, you attack a handle directly to the LAMBKIN logger. Process logging control with log output. We have file or console. Controls where it's to process std out or error go, and can be configured independently per process. File, the default, writes log files under the iteration directory, and console routes so process output straight to the terminal. The CLI is what runs your benchmark script and ensures everything child process is tracked and cleaned up automatically. The general shape is LAMBKIN, script, SDK option, and custom options. Your own LAMBKIN option flags sits along the SDK building ones. a fee worth calling out, diagram logs command without executing them. So variants prints all variants with their numbers and exits. Handle for picking a subset. Variants, for example, 1, 3, 5, run just that subset. No cache force a full rerun. By default, LAMBKIN skips iterations that's already completed successfully in a previous run based on the hash of their inputs. And log level and log output that are the two logins controls we just covered. Output register a function as a callback that runs once after the entire benchmark loop completes. It receives the benchmark context, not a variant or iteration one, since by this point, every iteration has already finished. Hook names must be unique. The convention is to read artifacts from the disk via context base, not to call context cell or launch new processes. At this point, the run is over, so this is only for analysis. In the example on the right, iterating over results with LAMBKIN data Evo series, plotting error against time for each variant and iteration, and saving the figure into context-based zero. This is what a full benchmark looks like. End to end. One thing before reading the code is that decorator orders matters. They are applied bottom-up, so the innermost one runs first. In practice, LAMBKIN benchmark goes on top, your LAMBKIN options flags below it, and LAMBKIN wears everything together in the right order. Walking through it. We define variants with name product 5 iteration and clock rate. Inside the function, LAMBKIN process background launches a recorder and an algorithm in the background while the player runs in the foreground, blocking until playback finish. An input hook resolves the datasets, and two output hooks, plots and stats, generate a chart and log RMSE, min and max, using LAMBKIN data Evo series and LAMBKIN data Evo stats. Everything reads as a normal Python. The SDK handles iterations, options, inputs, and process lifecycle underneath. Now, let's see all of this working of a real example. We have applied LAMBKIN to Beluga AMCL, a probabilistic localization algorithm. The dataset is a pre-recorded MCAP bag with laser scan data and a ground truth trajectory. The metric is absolute post-error compute with EOAPE, and the sweep is the cross product of sensor model and number of particles. To ensure reproducibility, the example sweeps with its own Docker and Podman environment. Two profiles are available. Developer mounts the repository as a volume, so code changes are reflected immediately without rebuilding. This is what we use during active development. Production builds a full self-contained image with all dependencies pre-installed for reliable execution in control settings. Both runtimes require elevate privilege to support background process management. Docker runs with privilege and Podman with system always, which is what allows to interact with the host cgroup v2 hierarchy. Here is the full Beluga benchmark. On the left, the script nominal launch ROS2 record in the background to record all topics to output. ROS2 launch in the background to bring in the localization stack, Beluga AMCL, map server, and lifecycle manager. And ROS2 backplay in the foreground to replay the dataset, blocking until playback finish. Then, Evo APE compares ground truth and pose and writes the result to output APE zip. Two input hooks resolve the dataset and the map from data. On the right, the two output hooks plots generate the AP time series chart for all variants and iterations. And stats logs RMSE, min and max for each one using LAMBKIN data stats. And below, you can see the real results. The table with RMSE, min and max for each variant and iteration, and the actual AP time series plot. This is the real output of running the benchmark. So that concludes the phase 6 presentation of the LAMBKIN AS SDK. I'm happy to take any questions.
Hi, Teresa. Thanks a lot by the presentation. This is a really, really new approach that will help a lot in the use of this tool and in the development of Beluga that we are doing. I want to open questions. I don't know if someone has any question about the project. Sure, Mish.
Right, thanks. First of all, and I think I already told you this, thank you so much, Teresa, for taking the task head first of yeah, reworking a rather old project that we are still having to deal with despite the rot. That said, I wanted to get a sense of where we are with respect to the original project of the earlier version, in terms like feature wise, and beyond that, after having worked on this for I don't know 3 months, 4 months, where do you see the project going moving forward?
I think, like, you said that in 3-4 months, maybe, what is the future for the project?
I want to understand how the new version compares to the old version.
Okay.
And besides that, how like what's your best guess of the extrapolation of the project? Like you build a number of features. What things do you see that could be added and that will be, you believe that will be beneficial to benchmarking in the context of the project?
I think the most difference for the new generation of LAMBKIN and the previous one is like, this is you can make your benchmark with everything algorithm. Is not you don't have to use, for example, ROS2 or Beluga AMCL. You can use your own algorithm, and the LAMBKIN doesn't have to know how this algorithm works. So I think it's the most, I think it's the best thing for this project. Obvious it's not finished, because in the next phases, maybe we can do some report that the previous LAMBKIN have it, that makes a real report. We have a lot of information with the CPU or something more that is very important, and I think this data is very useful in a benchmark. So in the future, we can do a report. Maybe we can fix some issues that maybe is not as well as we can do it in the time, and maybe it's a very good time to do it.
Thanks. So next, Hera.
Yeah. My question is related to Mitch's first question, and it's if you try to replicate the existing benchmarks that we have and that we regularly use, which are, for instance, AMCL versus AMCL to compare to different configurations, and the other one is NAV2 versus AMCL to try to see if they match in performance. And if it's not yet possible because we are still lacking features in order to do that, how far are we from being able to replicate those benchmarks in this new framework?
Okay, so you want to compare two different benchmarks with the same algorithm or with two different algorithms?
I mean, how far are we from being able to describe the same benchmark, the same experiments that we currently have benchmarks for in the old LAMBKIN with the new LAMBKIN?
Now you can make the same benchmark with the SDK, because the SDK is useful. You can evaluate your algorithm because everything runs and everything it's okay. The only part that maybe we can do in the future is the report, to make a report that PDF or something. We consider that make a Jupyter notebook, that in the Jupyter notebook you can use the SDK function like LAMBKIN data Evo series maybe, and you can go for the outputs and evaluate with the tools that SDK gives you.
Yes, Xavi.
So just to build a bit on what Teresa just said, I don't know if the benchmark that you're referring, Hera, also uses CPU and metrics like CPU usage. That is something that we currently do not support because we had some issues with basically C groups v2. So LAMBKIN relies on using C groups v2 because that is what guarantees proper process management. So for every iteration, we take care of the life cycle of all the process, and we can actually tear down all the process so that we can start from a new and clean state in every iteration, which is something that I think was done with Robot Framework previously, but I think still could have some issues. Because of us now using C groups v2, there is something that we need to fix on the creation of C groups that right now does not allow us to monitor the CPU and the CPU usage and memory usage of all the processes that we are running. So this, if we would like to benchmark this is not possible. But if we want to benchmark anything related to Evo, we can do that. Basically, LAMBKIN right now allows us to run any process, PROS2 related, Evo related. We manage any Python package that can be installed via PyPy. So if you need to do something with another package, you can bring it in easily. It's not that basically dependency hell as the previous LAMBKIN version. I don't know if that answers your question, Heda.
Yes, thanks.
Perfect.
Okay, thanks, Xavi. And now I saw a question of Agustin. First, he said that a wasn't work, and he asked about your perspective about what you like and what don't you like about this this framework, this SDK, because he imagined that while developing, you have been running multiple LAMBKIN to try out. So, which are your recommendation as the developer of what could be next in this software, or what could be made better?
Okay, so the question is like, what parts of the new LAMBKIN you don't like it? I think it's not a part of LAMBKIN I don't like it. I think every part of the LAMBKIN makes a part of the SDK. Without source, we can do everything. Without context, without everything is important. And what I like the most, maybe the context is a very good part of the LAMBKIN, because it's like the brain of the SDK. The benchmark is like all the life cycle of the benchmarking, but the context is the brain of it. Without it, everything doesn't work. So imagine while developing, you have been running multiple times LAMBKIN to try it out. I don't know what you recommended. We have to running multiple times the same benchmark. I don't know if this can help. But with the no cache, or maybe with we have like a cache with the times you run the benchmark. Maybe we try it, and you have 80 iterations, and in the 79 broke, and you have to make all the iterations for the beginning. So we do the cache that all the iteration that works, it's in the cache, so you only have to do the last one and finish your benchmark. So I don't know if Agustin it's telling this, but maybe it's useful for the people.
Okay, that is a great functionality, Awesome. Thank you very much, Teresa. I don't know if someone else has any questions. If not, I really appreciate your time and your support in this internship. All of us are very happy. So we are right now is our turn to meet together with Mish, Xavi, and so on to see how we continue moving this project. Thanks, Teresa.
Thank you so much for the time, and have a good day.